There we go. All right, so we're going to talk about vectors and what we can do with them. So a vector is a directed line segment with an initial point, usually at 0, 0, and a terminal point. Vectors are identified by magnitude and direction. So it's not just a line, it has weight to it. Vectors are identified by magnitude and direction. That is to say, magnitude is length, basically, of the line. So instead of saying magnitude, it's basically just the size. Okay, that's what I meant to say here. Vectors are represented by an arrowhead pointing toward the terminal point. The position vector has an initial point at 0, 0 and a terminal point at AB. So the head of the arrow is A, comma B. Okay. So if I give you 2 points, you can find the vector through them. I'll show you how in a moment. But in physics, I'm sure if you've taken physics before, and other science classes too, vectors represent like friction, different types of forces, basically. It could be gravity, it could be opposite and equal reactions. It depends. So like you have an object, let's say you draw a square and it's on the ground, right? There's gravity affecting it, and there's an opposite force pushing back on it. So those would be two different vectors, a positive and a negative vector. And the magnitude would be the amount of force. Okay. So they mean something. In math right now, we're just doing general because math is always very general, but it means something. Okay. To find a vector V, put a little hat on it. Through, let's say, we have a vector or a point P at AB and Q at CD. Use this formula. So V would equal to D minus A, comma, C minus B. Using the vector notation, you put little triangular brackets. Or you can use the IJ components, would be D minus A I plus C minus B J. But honestly, all you do is you take the final point and you subtract the initial. That's all you got to do. I think this is more complicated than it needs to be. Let me show you what I mean in example 1. And I'll wait a bit. Okay. So example 1, I'm going to give you 2 points and just find the vector through them. That's it. So the homework will start off like this. Find the position vector. That's what this is called. Through P and Q. where P is a point 2, 3, and Q is the point 6, 4. Okay, so all you got to do is take the final point. So do the X's and the Y's, or the I's and J's. So when you do vectors, the X component is they use an I notation in the book. For Y is J. If we're doing 3-dimensional vectors, you would have a K. Okay. We're not gonna do, I don't think we're gonna do that. I don't remember. But anyway, you take the X part, subtract the other X part, the final point minus the initial, then the final point minus the initial. So the vector would be 4, 1. Okay. You know what? Let me put this down here, so I could show you 2 different ways. Yeah. Okay. Now, if you use the other notation, you would say 6i, because that's the I component, minus 2i plus 4j minus 3j. So you would get 4i plus a single j. So this is the same thing. Okay. So take a little hat that denotes a vector. You see that they're saying that this is a vector, not a point. Okay. And the book, they might have it bold, but I can't really write in bold, so put a hat on it. But yeah, if you see either one, okay, this is vector notation. The book, I think, will switch back and forth. So make sure you know what they mean. This is 4i 1j, 4i 1j. Same thing. Visually, you would draw this, right? They didn't ask us to. You'd say 1, 2, 3, 4, 1. We'd have a point there. The vector would be this. That's it. That makes sense. So same thing, meaning this. And then we'll find out how to calculate the length. Okay. Any questions on the first one? Let me give you the formulas to calculate magnitude and direction. Because they're going to ask you, all right, what's the magnitude of this vector, i.e. the length? And then what is the angle, the direction of that vector? Okay. Turn the page in a moment. The angle and direction becomes important, or direction. If you're taking engineering courses, you want to know what angle that force is coming, or which way it's turning, etc. That'll push or make the object react in different ways. Okay. So let's find the magnitude and direction formulas. So given a general vector, written either this way or the other way, same thing, right? I don't care how you write it. The magnitude will have like a double absolute value bar on your vector, which you would find using this formula. just square A and B and add them together. So it's related to the hypotenuse, right? So if you draw a triangle using the vector as your hypotenuse, then the length is your hypotenuse. So this is your magnitude or length, same thing. Theta is equal to tan inverse of B over A. This is the direction of the vector. An extra note here. Two vectors are considered equal if they have the same magnitude and direction. Start another example in a moment. On this next question, and then on this next question, find the magnitude and direction. With an initial point P, -8, 1, and terminal point Q, -2, -5. So for sure, ask a question like this. I'm gonna give you 2 points, and you're gonna have to find the vector, and then find the magnitude and direction. So all you're gonna have is the 2 points to start with, right? So it'll combine question 1 and 2 to one better question. So vector V is simply the final point minus the initial. So -2 minus, oops. -2 minus a -8. And then the y part of the j -5 minus 1. So this will become -2 plus 8 and -6. Yes, yes. Are with me with the vector part. And you see it straightforward. You just take the final point, whatever it is, back out from the initial. That should be P minus plus final point for the y squared minus the y from the initial. So once you have it, then you can find magnitude and direction. Okay. So that part clear? Okay. Once you have it, just use the formulas. No big deal. Magnitude is a symbol for magnitude. In the book, they have like a bold version. On paper, usually we use 2 bars. I forget what they have in the book. So square root the a squared plus the b squared. So that'll be 36 plus 36. That reduces to what? Yeah, there's a 9, but there's also what, 36, right? Times 2. Okay. You agree? That's the magnitude simplified. Okay, cool. Yeah, one answer, another answer. Now they want the direction. So use your tangent inverse, kind of like we did before. Similar. Tan inverse of, we said B over A, right? Okay. So that will be equal to tan inverse of -6 over 6. The calculator will give us -45 degrees. Because tangent is stuck on the right half of the circle. Right? So the vector, if we were to draw this out, because I'm out of space here, the vector would be going over here, but -45. So the force would be coming down that way. And the amount of force would be the length, 6 square root 2. Assuming they were forces. Currently, they are just vectors. That makes sense? Yeah. The definition of for tangent inverse, the range is always going to be on quadrant 2 or quadrant 1 or quadrant 4. Same with sine inverse. The values that come out, the angles that come out are only on quadrant 1, quadrant 2. So look at domain and range for the inverse function, then you'll know where they come out. Cosine is the top half of the circle. I think we mentioned it a long time ago. Okay. They didn't ask us to draw it or graph, but there it is. Do you have any questions on example 2? So there's also an algebra of vectors. You can add them together, subtract them, and they have their own type of multiplication called dot products. It's not really like times, but it kind of is. It's different. It's their own operation. They also have a cross multiplication thing. Anyway, let's turn the page. You guys cool on this one? Well, let's talk about adding first. I think this is the last section before test 3, so man, we gotta decide on a day for the exam. Adding and subtracting. Although this test will be easier than the last test. Last one was the hardest one. Adding and subtracting vectors given u equal to 3i minus 2j and v equal to -1i plus 4j. Find u plus v. I just add the i's and j's together. That's it. So 3i plus a -1i. And then minus 2j plus 4j. Okay. So this will be 2i plus 2j, right? That's the new vector. Now there's this idea, we're gonna have to graph it, but where you can add them visually, and then you get a bigger vector. But I need to show you. I need to graph each one separately so you can see what I'm talking about. And I'm gonna try my best to be exact because it needs to be kind of perfect when you graph it. So the first u was 3, -2. So you agree that it's right here, right? There. This is u. Now graph v over here. It's about there, correct? V. So the idea is you add these two vectors, tail to tip, and then you draw a hypotenuse, and that's your new resulting vector. Okay. So we know what the answer is. It's 2, 2, right? So graph that first so you can connect the dots a little easier. So there's the answer. If you were to graph this guy was this one was -3, 2. So here's the original. Oh man, missed it. So this guy right here is u plus v. That was our answer. Okay. I'm gonna go ahead and graph the u and v on the same graph here. Okay, so you can see it. Try my best to draw. So here is u. And then V is this one. So what you do is you connect this tail to this tip. So UV, and you create like a magnet, a hypotenuse. Does that make sense? So when you add two vectors together, connect them this way. So U and V, and the result is always going to be there. So if you didn't have the numbers, you could glue these together and find out what it's supposed to be. Does that make sense? And we don't need to know what U and V is. You have pictures. It'll always connect that way. Okay. Now, yeah, yes.
So you're not seeing it from the-
Yeah. Just picture of you're cutting out, connecting here, so that result right there. Even though technically the V's over here, but the result is going to be here. That makes sense. Let's see if I can find a nice picture for y'all, because I know mine are horrible. Here we go. Some more examples in the book. Bring the book over. All right. Look at the original first. Let's say this is your U right here. And your V is this one there. So U plus V, you connect them. Here's one, and V, connect them together, and that result is here. Now, you put a negative on your vector, so you see how V is going this way. Put a minus, then you just go in the other direction. Negative just went backwards. So it's U is this way, negative U is that way. So it's all the same. Okay. And you can add and subtract all kinds of ways. Now, if one is I guess, stronger in a current in a certain direction, then it'll kind of push the result in that direction. Over here, we call this the parallelogram rule. So if you have your U and V, right? U is going this way, V is going that way, then the result should be go in that direction. Yes. It's just an example. I mean, if you put a minus on it, see how B is going that way. Negative B just makes the other direction. Yeah, those like, for example, the next example says, what is U minus? You just subtract. So you can add a vector, subtract them. Depending what you're doing, it'll shift them in different ways. So yeah, it'll be in the question. Okay, so if it's plus, just remember, make that hypothesis. If it's a negative, then you can connect them differently, right? U is still going this way, but V is not negative, so you connect the tail with the second vector to the tip of the first one. But now, U minus V is going back. So that makes sense. Okay, let's see if I can throw that in. Okay, let's do another example. First, I need to give you scalar multiplication before we talk about negative B's and stuff. Scalar multiplication. So given a vector, V equal to A comma B, and a real number, K, K times the vector V would basically scale the vector. That's why we call it a scalar. It just, if it's times 2, you would double it. If it's times 3, you would triple it. You just multiply every part by K. That's it. When scaling a vector by K, only the magnitude changes unless K is negative. Then the direction reverses. So we were talking about earlier. U versus negative U is the same thing as just going the opposite direction. Okay. Okay. It's another example. Excuse me. Let's do a scalar multiplication type. Just remember that the notation is the same. They could have used KI plus KEJ, right? Doesn't matter. Yes, go on this page. Example 4, I think. Given the vector v equal to 3, 1, find for part A 3v, part B find 1/2 v. So the 3 would triple the size of your vector, and the half would just cut it in half. Right, the magnitude would shrink. But the direction wouldn't change. It's still going the same direction, it's just bigger. So this would be 3 times 3, 3 times 1. This would be what? A half times 3, a half times 1. Nothing crazy, right? Just multiply each component. I think scalar is pretty self-explanatory. Do you have any questions about example 4? So the first few questions will ask you find a vector, then magnitude, direction. Then you'll have addition and subtraction of vectors. Then you have these scalars. Okay. The next one combines the last 2 examples into one. So given a u, I'm going to use the other notation, 3i minus 2j, and v equal to negative I plus 4j. Find 3u plus 2v. You're going to scale them first and then add them together. Okay. All right, so this will be 3 times the vector 3i minus 2j plus 2 times negative I plus 4j. So that's all we're saying with the scaling. So scale the I and j component. So it'd be 9i minus 6j plus a negative 2i plus 8j. Is that okay? You can put the i's and j's together if you want. 9 minus 2 and negative 6j plus 8j. When you see this in the homework, just multiply them first and then add them together. That's it. If it's in this form, then just remember what I and j's are. They could have used this notation or this. Doesn't matter. They're gonna switch it up on you. Okay. Don't let it mess with your head. All right. Let me give you something else. This is the unit vector. A lot of stuff in this section. If V is a non-zero, if V is non-zero vector, then V divided by its magnitude is a unit vector. In physics, the unit vector is pretty handy, but in this class, they're just going to ask you to find it, and that's pretty much it. Just know that it means it's the same vector going the same direction, just shrunken down to a unit of 1. Okay. So we call this the unit vector u equal to v divided by its magnitude. Where u is the unit vector of v. I think I have room for example 6. Find the unit vector for v equal to negative 5, 12. So in order to find it, you're going to need this formula that we just wrote down. But as you can see, we're going to have to first find the magnitude to use it. So we'll do the magnitude over here. Magnitude of v is the square root of each component squared. Right? This will be 169, which is 13, right? So just take the V and divide each piece by 13 and you'll be done. I'm gonna use the other notation. Well, you agree that dividing is the same as multiplying by a fraction. So I can write it this way as a scalar. That's the same as dividing by 13. So each piece gets 13 on the bottom and you're done. This is your unit vector. Here. This is what they want. So if you were to find the magnitude of this guy, it's going to be 1 because of what we did. Okay. This is B here. This is the same as divided by that. But 13 on the bottom one, or kind of 113. This is the magnitude, right? You have to divide by magnitude. If you prefer, that's weird. Yeah, let me change it. You agree that this is the same? Right. That's what I had before. I just thought the other one was prettier. That's the only reason I did that. Like, it doesn't matter. Because we have scalar multiplication. There's no actual division. So it's weird to write it this way, but it's okay. It's not a big deal. Okay. Any questions on example 6? All right. I'll turn the page in a moment. Section is very long, so bear with me. Vector components. So you can decompose a vector into trig functions. So given a position vector V equal to x comma y and a direction theta, cosine theta is equal to x divided by the magnitude of V, which means that x is equal to the magnitude times cosine. Sine is defined as y over the magnitude. That looks weird. Y is equal to the magnitude times sine theta. So if you were to write the V, we know it's supposed to be xi plus yj, right? Because that's what we set up here. x comma y. But if we change it, you see that this is also equal to the magnitude times cosine plus the magnitude times sine, right? Just substitute the x and y. But that looks weird, so you can factor this out and have cosine theta I and j like this. So V can be written in terms of cosine and sine. You can change the x and y components, ij components, into these trig functions, which is pretty useful. We may not apply it here, but it becomes very useful in physics. And if you're not going there, then you won't see this again. Yeah. Yeah, so I'm replacing the x, but that I is still there. I'm substituting x for this and the y for that. So if you have the angle and if you have the magnitude and direction, you can switch to cosine sine. Okay. This also means that the magnitude, which we should know, is equal to x squared plus y squared. All right, let's do another example. So given all this info, let's apply it to something. Find the vector v given the length. Given the length of 7 at an angle of 135 degrees. So I'll wait a bit. Okay. So what we have is magnitude, right? Magnitude is equal to 7, and theta is equal to 135 degrees. So x is equal to magnitude times cosine, right? We just plug it in, that's it. So this will be 7 cosine of 135. All right, well, 135 is quadrant 2. So that'll be 7 times the negative square root 2 over 2. It's straight from the unit circle. That's all that is. So this will be negative 7 root 2 over 2. That's what x is equal to. So do the same thing with the y and we're done. So y is equal to the magnitude times sine theta, which is equal to 7 sine of 135, which is 7 times square root 2 over 2. It would be positive in quadrant 2, and that's our answer. There's my x and y. I'll write it as a vector. It's got x and y, in other words, are a and b parts. So vector v is equal to this thing, comma, this other thing. These are basically they're very similar to or almost exactly the same as less than or greater than, the way they look. I just can't draw very well. Okay, so same things on the keyboard, triangle and bracket, but they're not less than greater than, but they look exactly the same. Just pointing out. If you write it the other way, that's also cool. I don't care. IJ. Okay. Any questions on number 7? If you have magnitude and direction, you can find the vector v using those formulas. That's all you got to do. All right. I don't think I have enough time to do much else, but yeah, it's cool on this page. There's still 2 more ideas in the section, surprisingly. Dot product and angle between. Let me just give you the formulas and we'll call it a day because this is a lot already. The dot product of 2 vectors and u equal to CD. If you were to dot them together, it's kind of like multiplication, kind of. So if they tell you to dot 2 vectors, they mean multiply the A component and the 2 I components together, and then the 2 J components together. But you're gonna get a number. You don't get a vector back. Okay. And we'll do examples next time. Let me just give you one more formula and that's it. The angle between 2 vectors is related to the dot product. So the vector between the angle between U and V. So cosine theta is equal to V dot U over the magnitude V times the magnitude U. So that implies that theta is equal to cosine inverse of V dot U over the magnitudes times each other. So it's supposed to be a double arrow. Okay. And we'll talk about this next time. Okay. Sadie,
Here.
Jadlyn, Ava, Andre, Zoe, Aaron, Michael, Alexandra, Juan, Juliana, Epifania, Andrea, Kimberly, Diego, Teresa, Hunter, Angelica, and Connor. All right. All right, guys, we'll continue this next time.